Also some newcomers. Anyone who is a newcomer, could you just give me a quick show of hands? Fantastic. It's good to know. So this overview will not be entirely without merit. So ExoGENI is one of the two RACS projects that was sponsored by GPO. Ours is the one that, shall we say, is focused on perhaps larger hardware with greater isolation is really our focus. We have 14 racks that are funded by GPO, and it's a partnership between RENC, Duke University, IBM, and we are using IBM hardware here, and that's getting ready to start changing. We are actually working with other partners. There are some institutions that are using Dell and priced out rack hardware based on that for ExoGENI, and Cisco is also getting involved with us with a couple of racks. So stay tuned. But for at least this initial phase, we're using IBM. Each one of the racks is basically a small networked cloud. It has local storage adequate for hosting virtual machine images, bare metal images, all that sort of thing, and also for doing storage slivering, which is a feature that we intend to support in the near future. We use OpenStack underneath in order to provision the VMs, so all of these VMs are KVM based on Linux. Right now we support mostly Linux images of various varieties in the VMs. We are working on trying to get Windows support there, and I believe that's correct. Stay tuned on that as well. So, as I said, we use OpenStack for the VM hardware. For bare metal, we use XCAP, which is used to provision both the workers that run virtual machines as well as the bare metal hardware. It's a separate set of definitions inside of the XCAP configuration. Allows us to switch things very flexibly. Operators of an ExoGENI rack have the ability to decide how many of the resources they're going to delegate to all of GENI and how much they're going to retain for themselves. That is part and parcel with the Orca hardware, with the Orca software. Orca allows you to determine how many resources within the rack, how many VMs, how many bare metal instances, how many VLANs, that sort of thing. You're going to partition between the service managers that actually handle the creation of topologies. Because we're using OpenStack, we use EC2 as our primary interface, although we're looking at supporting some portion of the native OpenStack API. We also use the EC2 standard image format, that is an AMI, AKI, and ARI RAM disk, initial RAM disk, kernel, initial RAM disk, and file system. So that should be familiar to anyone who's used EC2. The software stack is as follows. Basically, we've got the substrate, which is comprised of the rack, as stated, dynamic circuit frameworks, and an open flow switch that's built into the rack. And on top of that is a melange of XCAP for provisioning the bare metal, OpenStack for provisioning VMs, Nagios for handling the monitoring of the entire layer, FlowVisor for slicing the open flow switch. And on top of that are the APIs we use to go ahead and provision portions of that substrate, that being the Orca API, the GENI AM API, and Foams API, which is also ideally Milke. The racks themselves are installed with CentOS 6, and pretty much I've covered all this information already, so we'll go on. I'm getting ahead of myself, apparently. This is terrible. As stated, all of the GPO-funded racks are through IBM, and NICTA's rack in Australia is also IBM hardware. Cisco is working with us on the NC State rack that we are going to be showing in the demo session this evening, so that should be something all of you will be interested to look at, I hope. And folks in West Virginia are also deploying Cisco racks. The folks working with Dell right now are at the University of Amsterdam, but there are other racks that are in the planning phases that are going to be using quotes from Dell to help build out an ExoGENI style rack. So just to give you a quick look here, basically there are 3 connections. There are optionally 3 connections, but minimally 2 connections to an ExoGENI rack. One goes to the campus layer 3 network, the other goes to a dynamic circuit backbone, and this is a rough idea of how the layout is for an ExoGENI rack. We have got 4.5. We don't operate in integral numbers here. For the new racks deployed, RENC, GPO, Florida International, and NICTA are the racks that are currently online. University of Houston is currently in testing, and we have 4 more racks ordered, and that's for the University of Florida, UC Davis, OSF, and the Starlight facility, and all of them are connected using the BEN Breakable Experimental Network that is hosted through RENC, Learn, NLR, FrameNet, and eventually we will be hooking up through I2 as well. And to give you an overview of how all of this gets put together. So, we have most of our connectivity through NLR to the various sites. There are a couple of connections to OSF and DOE through ESNet. And then through I2 and I2 ALS, we hope to be hooking in NICTA very shortly. Ben connects Duke, UNC, and RENC for topologies that folks want to try to construct within ExoGENI. Are there any questions thus far? Have I moved too fast? Are you in a coma? All right. So we've discussed, in effect, how ExoGENI is laid out in terms of substrate. But what we haven't discussed is how to actually use it. And I suspect that's what's more of interest to you guys here. The tool that we have made available, and it was written by Ilya Baldin, and all praise to Ilya Baldin for this, is named Flukes. It is a graphical tool written in Java that permits you to take a set of virtual machines or bare metal hardware or whatever and link it together in various ways to draw out your topology for your experiment. If you wish to install Orca yourself, easiest thing for you to do is to just go to Google, say GENI Orca Flukes. It'll be the first link on the page, I assure you. Your EmuLab credentials, your GENI portal credentials will work, and there are instructions on this page to show you how to take the credentials that you receive and convert them into a JKS, a Java key store, because that's what Flukes uses in order to be able to get the credentials to actually be authorized to create any kind of topology on your behalf. So, without further ado, I will go ahead and launch Flukes so we can begin trying to draw a demo topology. Takes a couple seconds to start. And here we are.
Quick level set question while you're...
Please.
Flukes is running on your Mac.
It is running on my Mac, and it connects.
Talking to Orca.
It is talking to Orca remotely. So, yes. Let me go ahead and explain what the gentleman over there is asking about. Flukes is, in effect, a front end onto Orca's service manager, and you can configure any number of service managers. Each of the ExoGENI racks runs a rack local service manager that you can connect to with Flukes if you so do choose, but you will only have access to the resources within that rack, that is the OpenFlow switch within that rack, as well as the VMs within that rack. There is a central ExoSM, Exo Service Manager, that has collections of resources delegated to it from all of the racks that allows you to use the dynamic circuit frameworks to create topologies that span racks. That makes sense to everyone? Fantastic. So when you start up Flukes, you are presented with a delightful blank screen, but that does not have to stay that way. The first thing you're probably going to want to do after you've gotten your credentials set and been able to start up Flukes is you may want to go ahead and log into the controller that you're going to be using. We're going to use the ExoSM right here. And I'm going to go ahead and enter in my credentials. Hopefully they won't be echoed, but there's never any actual certainty of that. And after a couple of seconds, once Flukes has had a chance to connect to the ExoSM, there we are, we can go ahead and go about starting to create a topology. This is as simple as click Add Nodes and just go ahead and click on that blank space. Let's go ahead and say I want to create a topology of 3 nodes. Does that make sense to everybody? And I think we're going to create links in between them, thus. Now, we have a general idea. We have 3 nodes connected by 2 links. What we want to do is customize these. Bless you. If I right-click upon these nodes, I can then edit the properties of those nodes. I can give my node a name that's more descriptive and useful to me for when I'm going to be looking at it in the manifest view, which I'll describe in a little bit after I've gotten done explaining how to create a topology. I can then select an EC2 image size. And let me say that while we have labels on here for the image sizes, they do not necessarily correspond to Amazon's. We have a page that describes roughly what the sizes are in terms of memory and in terms of core count. Right now, they're all single core. Multi-core is foreseen in the short-term future. You can then select an image. We have a set of 2 or 3 sample images. You can feel free to create your own. ExoGENI staff can help you in terms of building yours, but I mean, for right now, in terms of this demo, we're going to use this standard multi-size image, and that often works well for a lot of folks. We also have an OVS-enabled one, which we'll be discussing in a little while, and that might be fairly interesting to folks who want to try to start playing with OpenFlow inside of ExoGENI rather than necessarily using the hardware that underpins ExoGENI, that is, the OpenFlow switches that are within it. The next thing that we would want to possibly select, let me go back and select that size. That might be useful to us. Otherwise, things might not quite work as we expect. The next thing is your placement. You can ask for the SM to try to place the nodes however works best for that SM or however resources are available. If we had selected one of the rack SMs, we wouldn't have all of these choices. We'd only have one. So if we say system select, the system is free to choose where it places nodes. In this case, I'm going to go ahead and put a node at Duke for right now. The other thing we can also say is that this node has a dependency, that another node needs to come up before any given other node. And we can specify that here. We are not worried about that at this time. Last but not least, we can configure ports to open in terms of TCP and UDP. That is something that we are having to reestablish functionality on because of some changes in how OpenStack works with OVS, which we also are using for the aggregate. That should be functioning again shortly. You need to configure the IP. This is the data plane IP. Each node will come up with 2 interfaces. For example, in this situation, you see node 0, you see node 1, and you see node 2. Each of these VMs will start with one interface, which is going to be a management interface. It is not part of the data plane. When you create these links, they are allocated within the data plane only. And you need to configure them with the appropriate IPs that you would like. If you wish, you can choose not to put an IP on them, but then that would require that you manually configure the IPs once you log into those nodes. Or you could do something like running DHCP inside your topology. That's something that you could choose to do. In this case, we're going to go ahead and set ourselves some private address space and just set up one IP there, and that should work. Actually, I'm going to call this 2, just for my simplicity's sake. And the last item that you can customize is a post-boot script. If I click on that, you can fill in whatever text you like here that can execute in a regular Unix shell. And that will proceed forward. You can also choose another interpreter, but most of the time we see folks using just plain bourne shell commands in here in order to further configure their VMs. The scripts within this particular window can also be templated there is a template language based on velocity, and there are properties that have been propagated into the velocity engine running inside of Orca that allow us to probe, for example, the IP, the node name, things of that nature that would be helpful to you. There's lots more information on the web describing how to do that. All right. So I'm going to go ahead and rather rapidly configure these other nodes. So I'm going to go ahead and create another M1 small and another standard image. I think I'm just going to put the whole thing, I think I'm going to put this one at Duke and the other one I'm going to put at BBN just for our entertainment's sake. So I'm going to put in matches. For everyone's benefit, don't make the error I did and assume that a dot's going to move you to the next field. You actually do have to tab them up. It's very lucky you have an inept presenter. That way you can learn from my errors. So now, we've roughly configured our VMs here, and they each should have IP space. It's occasionally useful at this time to go ahead and check, make sure that the IPs make sense to you in terms of your topology. This all looks good to me at this point. I'm feeling pretty happy about it. Now, the other thing I'm going to say is, gee, I haven't said anything about these links, have I? You can right-click on them as well. You need to target carefully, but you can choose what the bandwidth is going to be on any of these links. So right now, between the two Duke VMs, I think I'm going to be happy with 20 megs a second, and between GPO and Duke, I would like to move that to 50 megs a second. If I can type in the right place, we'll be great shape. Really, we will. We'll get through it, I promise. I did not mean to add that node, so we're going to remove it. Now, the other thing that is occasionally useful is if you have a large topology, you can zoom by scrolling the mouse in or out. And if you right-click in empty space, you have a number of features where you can edit selected nodes by choosing the pick mode. There's edit mode, there's pick mode, and there's pan. Pan allows you to move about the screen without adding anything intentionally. Pick allows you to select a given VM or two, or whatever. I'm surprised that it doesn't allow me to pick multiple. I'll have to talk to Ilya about that. Neither here nor there. So moving on. If you wish to specify your own images, you can do so through the Client Images button at the top. You can say New Image, and what you need to do is provide a descriptive name for yourself, a URL, and an SHA-1 hash. There's a description of the image meta format. If you all have questions about that later, let me know, and I'll be perfectly happy to answer them. So, other things we can do. We can select the default domain for the entire topology. If we hadn't specified it per node, we could have done it. We could have bound the entire thing to one particular site in this way. The other thing you might want to configure is the term duration. By default, Flukes has a 24-hour term that is just a default. You can increase that as needed. I think up to about 14 days is the current limit. That is intended to be raised in the near future as well. All right, so now we've got this topology, and we want to go ahead and launch it. So we need to give it a descriptive name. I'm going to say VJO playing in tutorial 0, just because, well, it's reasonably descriptive, I'd say. And then we say submit request. We wait a little bit for the ExoSM to get back to us after it's sitting there figuring out where it can place things. Since we said where to place them, it should be all right. I presume we're going to have enough empty space to do that. And there we are. And what we received back is a response from the controller saying what it had to do what resources it allocated in order to make this topology happen. At this point, we move to the manifest view. Here's where we watch our topology come up and see whether everything comes up okay. What we want to do then is click on My Slices. And we select a particular slice and we query it. We can choose to delete it if we don't even want to query it from that same area. What you'll next see is a current resource status. Your entire slice is considered active when all of the resources have become active. Resources can fail, which would result in an incomplete slice, but the slice at that point would be considered active. It would have completed and reached a final state.
Excuse me.
Yes?
Anywhere you can increase your font sizes.
Oh, gracious.
I can't see anything from here.
I apologize. Let me see what I can do for you. I think I'm going to decrease the resolution on the display, if that's all right, and that might make things a little bit better. We'll see if this works. If it does not, we'll be in. World of hurt. Well, while we wait for the display to come back, does anybody else have any other questions at this time?
Excuse me.
Yes.
I do have some errors while submitting my address.
While submitting what?
While submitting my slides,
Okay,
I'm seeing some errors.
certainly.
Uh,
Are you attempting to do this in real time with me?
yeah.
How about I help you after the session? It might take a little bit of determining what's going on. Please.
Who has an error? Who did have the error?
All right. Is that better? Is that more legible? A little. Oh well. Is that at least more legible?
Yeah.
Yes. Okay. These are going to be. I can zoom in to some degree, but we'll only be able to see very little, and I don't think the font actually increases when you zoom. So I apologize for that. All right. So until the resources, all the reservations all become active, we have to sit there and basically click query for manifest repeatedly until the aggregates have a chance to bring everything up. As of this time, well, we waited long enough with the monitor that everything came up, so we're in pretty good shape here. So as you can see, I've got one node and then a link between it, and then you may see that there's an additional set of nodes here, or between the two VMs that are at Duke and at BBN. And those are each of the switches in between for the dynamic circuit services that exist in order to affect our topology. So for example, this would be going through, I've already painted myself into a corner. We've actually got a little bit of a problem right now with the test bed wherein everything has to go through RNC. But it's unfortunate. Neither here nor there. Anywho, in order to affect a topology of this kind, each of these circuit services is spoken to by the appropriate aggregate manager within the Orca framework and has a reservation fulfilled when a request is made. So, at this time, I have these 3 VMs. I may not necessarily be able to ping over the data plane to them to BBN, but I can at least give you some idea of what we can do from here. So now that I've got this node, if I right-click upon it, it'll state again the image type used, where it was allocated, the size. I can then say delete node. Increase node group size, because this is a single node, that option does not make sense, so we can ignore it for this time. Let's take a look at view properties. If we view the properties, we can take a look and see how we would access this VM. And as we can see, there's an SSH URL that gives us an IP and a username. So how is it that we can get in as root? We don't have a password. One of the things that occurs when you start Flukes is that a .flukes.properties file is created. And this is something you'll need to customize before you start Flukes. I should have probably discussed it at the outset, but it's a lot more interesting to build a topology. Nevertheless, things that get set in here are passed to an xterm if it needs to bring up an xterm for an SSH, which will be useful to us when we right-click here and go to the next option, log into node. There's a need to specify what the script comment separator is for the scripts and the post-boot scripts. And this is how we actually manage to log in. We provide a path to the SSH keys that we want inserted into those VMs. And that way we're able to have the credentials that are necessary to get into the VMs we just allocated. There's additional things in here describing a registry of how to find the SMs that you would be able to get resources from. And also there's a description of where the key store is that you're going to be creating using that web page that I talked about earlier. There's where you take the Emulab credentials and you take your GENI portal credentials and convert them into a JKS. When you have your JKS created, you would specify it here. Moving on. So we know that we have an SSH key that was inserted into this VM. We can now say log into node. And let me bring the xterm back that it has just thrown over here. As soon as I say log into node, it uses the key auth to get me in. And at that point, we're pretty much plain sailing. We can run an ifconfig. We can sit there and ping our other VM that we allocated at Duke. I'm not sure if we're going to be able to ping one VM. We'll see. I'm betting not. Oh, live demo. I wonder what who's done in the Duke rack. Considering I'm the admin of it, I guess I got someone to talk to. Neither here nor there. So anywho, since we had a bit of a failure with SSH, well, we won't worry about that at this time. When you take a look, so when we were over here doing query for manifest, as you can see, there's still plenty of problems you can have, even when all of your resources have come up active. And that's usually the result of some misconfiguration in the aggregate. And the person responsible for that aggregate, in this case me, would be able to help you out in determining what's going on with the aggregate that would cause a problem with your slice. However, when we take a look at that manifest, we can also take a look at the raw response. And that raw response is what is used to produce that manifest that you're taking. This is the actual raw manifest from which the more user-friendly bit that you were looking at earlier is created. And it is NDL describing this topology and the state everything's in. Now, things that folks have asked us before that they would really, really like. Extend reservation. Perhaps you made a mistake when you started up your slice and said, gee, I'm only going to need it for 24 hours. And turns out that there's a demo and your advisor got rescheduled and it's going to be 3 days from now. Do you really want to do what I did and have yourself a live demo that doesn't work, or do you want to go ahead and pre-gen some things up and make sure that they last long enough for you to do your demo? You can go ahead and extend the length of your slice here. Going on from there, defunct, let me ask. When we do an extend, are we supposed to do a commit modify action on that? This is a new feature that I would actually need to ask Ilya about. So it may be that we need to do a commit and modify after we do an extend. I'm not 100% sure on that. So I will get back to anyone that has a question about using this feature. Anywho, after you're done with a slice, or you have a slice that failed for whatever reason, or portions of it failed, you know what? If there are failed portions of it, it may or may not necessarily be useful to you in that state. So the next thing you want to do is go ahead and delete your slice. You'll be prompted to choose whether or not you wish to do so. In this case, this slice is just sad. We're going to have to get rid of it. All right. Does anyone have any other questions at this time before I proceed to a slightly more interesting, perhaps, demo that I had the good foresight this time to actually pre-gen?
I have two questions. One, since you're the administrator of the obviously failed infrastructure, why hasn't you figured it out while you're standing up?
Because I have it on vibrate inside my bag. The better to ignore it.
And two, for us network geeks, the complicated looking line down there,
Sure.
is that a whole bunch of VLANs, or is that?
In effect, it is, yes. The dynamic circuit services allow us to programmatically ask for a set of VLANs at each of the services that allows us to have a circuit path that leads from one aggregate to another. That makes sense.
One leg of this topology is interdomain pass, and another one is just an intra-site thing.
Yes. The fact that the intradomain didn't work is my fault. The fact that the interdomain is also my fault because I chose a path that we know to not currently be working. All right, so let's go on to a little bit more interesting thing. So,
Can I add one thing?
please.
I think what's important, for when you use it, and Ilya points that out all the time, if you really don't want to have VMs at a specific rack, let's just do the ExoSM do the work for you.
Yeah, just select system select unless you really want to go to the trouble of picking which aggregate you're going to use.
That kind of prevents some of the, most likely prevents some of the issues
Yes.
you just had. So that, especially if you start, if this is the first time you're doing something with ExoGENI, I think do system select, it makes your life a lot easier.
So, going on to a slightly more interesting topology that will lead into Mike's half of the segment. So we have here an interesting little thing that has 6 nodes and quite a number of links in between. Now you may be wondering how packets could even sanely pass through this, and what I'll explain is that each of these nodes in the middle, these 4 nodes, is actually an OVS-enabled image. It's actually it's a Linux VM running Open Virtual Switch. So we can actually talk to it with OpenFlow and choose to push in flows. So what we're leading to here is, if any of you are interested in using ExoGENI to start experimenting and playing with OpenFlow with your students at this point, you know what? This gives you a nice, safe means of doing so that doesn't actually use your infrastructure in a way. If you have a campus OpenFlow network, you may not necessarily want to give your students immediate access if they're still learning how to do OpenFlow. So anywho, we pre-allocated this topology, and it is waiting for us to show you. Each of these VMs is up. We have Open Virtual Switch running on each of these with static flows put into place. We have actually set the controller to run on a workstation of mine in my office, and we are using the Floodlight Controller. Let me see if I can get you. One moment, my apologies, as I move things around. So here we have Floodlight, obviously doing something rather busily. It is actually chatting back and forth with all 4 of these Open Virtual Switch instances, Open vSwitch instances. these two, node 5 and node 0, which I realize is very, very hard to read for everyone, and I apologize for that, are actually end nodes that we have decided upon a path for by putting in static flow entries. So if I go ahead and go back over here, you'll see that I've been pinging back and forth to make sure things work. What I'm going to do is I'm going to go ahead and kill flow visor at this time, floodlight rather at this time. Oh, that's lovely. And this topology should still work because we have static flow tables installed. But how did we manage to do that? And this is where things get a little bit more interesting. Let me go ahead and show you how this topology was set up. This entire topology was allocated out of the Renzi rack. And we used an OVS-enabled image, which is one of the stock ones, so feel free to use it. It is among the sample images that are available to you through Renzi's site. And we have basically created, for each of these 4 nodes, a very small private class C. The 2 end nodes, however, are on a completely separate class C. All right? 192.168.2 versus 192.168.1/24. All right? So, over here, we have Floodlight with an appropriately configured properties file that turns off learning switch mode because we want to do static flows, which is kind of useful with the tool we're about to show. We start up Floodlight. Huh? We start up Floodlight when Java decides to work appropriately in my workstation back at the office. And it is connected to via each of the 4 Open vSwitch instances. Those Open vSwitch instances were told to do so in a post-boot script right here. Each of them also had a bridge created with the appropriate Open vSwitch command. And each of them was set to have a failure mode of secure, which means that when traffic does not have an active flow, it will not be allowed to pass through the Open vSwitch, period. We then add each of the 3 links that are associated with these nodes to the Open vSwitch bridge and go on from there. So now we have Floodlight running. The next thing that we want to start up is a graphical tool by the name of Avier that was written by Amherst College in conjunction with IBM. So when we launch it, we'll actually create a window here wherein we specify the IP address of the machine on which Floodlight is running. I'm actually SSH tunneling this through, so I'm going to say localhost. You can actually SSH tunnel port 8080 through to whatever machine is running Floodlight and be able to connect to it with Avier. And this gives us a lovely little window that tells us the current status of Floodlight, as well as the DPIDs of all the switches that are attached. So, we can see here that we have a number of DPIDs, and what we can do from within Avier is, first off, basically patch one port to another by choosing the DPID and then stating that you want to do a new patch. And you can say from what port to what port on that particular Open vSwitch instance. That's not terribly interesting to us in this case. The other thing you can do is you can use the Flow Manager UI, which allows you to select the vSwitch you wish to use. And you can say new flow. You would want to give your flow a new name in this situation. And then you would want to go through and specify actions. These are actions that are as specified, that are available through the OpenFlow spec, output and queue, strip VLAN, set MAC address, set source MAC, set destination MAC, things of that nature. Things that you can, actions you can take on a packet coming through. So when we were doing this demo, we would have selected output, which is just, as soon as we see the packet, the action we want to take is to send it out, and we want to state which port we want to put it out through. The other thing that we have to do is we have to match. So we can say on what things we want to be able to take that action. And in order to do so, we have to fill in some subset of these fields. We can say what input port the packet comes in on, and then choose to shunt it back out through another, which is where this demo was based. The thing I'm worried about at this point, of course, is I had pre-ginned up this demo. However, I don't see something that makes me feel warm and fuzzy, which is there are no static flows set. Had there been static flows set through here, we should have been able to ping through between those two VMs. And before I killed off Floodlight, I suspect there were static routes set. Neither here nor there. I think you're going to have to end up taking my word for it. Anywho. Yeah, we're going to have to end up taking my word for it based on old output. Nevertheless, Avier, I think, is going to be a useful option for everybody here if they would like to go ahead and have students that are unfamiliar with OpenFlow start playing with Open vSwitch. And it is a useful means of starting to play with OpenFlow inside of ExoGENI. I would suggest use our, go ahead and use our OBS-enabled image. Try to set up topologies of your own. Download Floodlight. The number one thing you need to do is look in the configuration. I'll show you that. One moment. There is a properties file that is properties file that's used to configure Floodlight. By default, it contains the learning switch mode. If you wish to remove that learning switch mode so you can play with static flows yourself, there's one item that you need to remove. And if you wish to play with this mode, please let me know. I can send you this information. But basically, we remove one line, which is this forwarding module within Floodlight. Anywho. I can send you this topology if you'd like to instantiate yourself, as well as some information for how to set up the static flows. This would have been a lot more impressive when I could have shown that we had a ping basically traversing this path, going from here to here, and then the ICMP request going this way, with the ICMP reply going this way. But apparently I've cut off my nose to spite my own face. Any further questions from anyone else with regard to my ineptness in this matter? And Mike will definitely be able to show you a much better demo than that.
Not sure. Let's see.
No? All right. Well, pleasure for you. Oh, sorry. Go ahead.
I'm not sure if it's relevant for the context of the course, but I'm looking at the VLANs and you are establishing between nodal aggregates. And my question is, obviously that's not something that's going to scale as you keep adding more and more experimenters and have a finite amount of VLANs and it's essential to allow broadcast forms to provide. Any thinking about evolving to have a sort of encapsulation like a MVTRE or VXLAN architecture that allows you to have your same replicas of private address of the experiment. If that's what you use your VLANs, or what are your thoughts?
That hasn't been discussed at this point. A lot of what we try to provide is layer 2 connectivity, just so that, I mean, are the technologies you're talking about capable of providing a layer 2 circuit? Because that's a fundament of what we're talking about here.
Yes. Like what you do for very large scale data centers in order to spin the multiple machines while containing the same addressing properties. Because I'm seeing that this could reach out quite a number of people that can support.
We might like to talk to you about that, put it that way. At this point, I think I'll hand it over to Mike. Oh, wait.
Does topology, support layer 3 connection, I mean IP connection?
So within the data plane, what we do is we primarily allocate layer 2 and leave layer 3 to you, so that you do not necessarily have to use IP. You can try some new, different models. This is intended to allow experimentation without affecting a production network. So you're going to have a lot more freedom available to you by being able to use layer 2. Layer 3, we don't necessarily allocate circuits in that manner.
Especially, I mean, that how would be possibility, for example, to emulate a BGP speaker router in this architecture? Is it possible or not?
It should be possible. You would have to probably allocate your own. It would be entirely done within the data plane, and it would probably be done as an experiment you yourself would set up. I don't think that you would be talking about exiting the data plane with that BGP setup. All right, it's been a pleasure.
Do you want me to write the microphone with me? I was going to do that. First, check what's going on here. So while we're waiting for the screen to come up, I would like to welcome everyone here for the second part of this kind of demo tutorial. It's great to see such a large number here. Let's see. This. Here we go. Yeah, excellent. So, this is just a demo I just ran. I just want to show you it's working. You know how this is when you want to do an actual demo. So this is the results. I'm going to show you in a minute. We're going to talk about this in much more detail. One important thing I want to point out before I really get started is, what Victor just presented, and I have the links at the end of my slide. We have created actually wikis that contain all the steps he went through and I'm going to go through, so you can go through it. I know when we do this up here, believe me, we all have this done 100 times at home, so to speak, right? So it's awfully fast for everyone to go and try to do this while we're doing it here. So there's wikis on the GENI webpage, on the GENI wiki, which tell you all the steps. I actually went through the pain of making videos where you can actually watch a tutorial video. I have 3 tutorial videos, which I also have the links in the slide, so you can look at this. So don't feel rushed, don't feel overwhelmed. There's time for you to go through this. You know how to find us on email, so if any questions come up, please follow us.
Please feel free to contact either of us.
Yes, absolutely. Well, let me just give you a little bit of an introduction here. I'm just going to find my mouse. Wonderful. Here we go. So So I'm going to talk about GIMI, which is one of the measurement tool sets, toolkits we're building here in the GENI world to actually do something useful, no pun intended here, with the wonderful ExoGENI and InstaGENI, test beds we have, because it's great to set up all these topologies, but we want to set them up for a reason, right? Maybe you guys have come up with a wonderful new application. You want to really see behind, NS2 and network emulators and simulations, how this is doing in the real world. Maybe you need layer 2 VLANs because you came up with the wonderful new version of that replaces TCP and you want to measure how it performs, right? So that's kind of, how do we do this? And a lot of our focus is actually about automation. And then, for now I'm keeping the numbers small with the nodes and everything to just, keep it relatively simple. But the long-term goal is really to make this scalable. We're building an infrastructure with, how many racks are we going to have in the end?
14, and that's not counting the ones that folks are buying themselves.
Right.
That
So 14 times 8 nodes, right?
Times 8 VM nodes, yes.
8 VM nodes,
So
right?
I think it's over 100 each.
Over 100 nodes you can actually potentially run in an experiment.
Yes.
You don't want to have to SSH into each of these nodes, right? That's going to be, very fun. So let me just give you a quick introduction of what we're doing here on measurement infrastructure. So we want to support your needs in actually performing experiments. So please also tell us what you need and what you'd like to do. We use, the OMF, the Open Measurement Framework, and the Open Measurement Library that has been developed by Max Ott and his folks in collaboration with the WinLab folks, and then at NICTA over the past 10 years. Can do a lot of very, very good stuff in terms of measurements. And we're using IRODS as the storage system here to have a permanent storage for our experiments, and I'll talk about this a little bit later. We provide libraries to instrument our experiments, to collect the data, and consume the measurement flows. I talked about archiving, and in the future we're also working into making this nicely fit under the policy and authorization mechanisms we have in GENI. We're not there yet. This is one of the things that are coming up soon. So we want to provide easy-to-use instrumentation and measurement services for experimenters. Now, what's easy to use is probably something we can debate for quite a bit. It's there's still a learning curve. If you learn a new tool, it's something where you have to invest some time. But we want to deploy, or we have deployed that in the ExoGENI world, and if people are going to the WiMAX tutorial tomorrow, they'll also learn how you can use it in the WiMAX environment. We provide a comprehensive infrastructure for measurement services for our plan is also to do this for infrastructure operators, so not only do it for measurements but also for monitoring. And we do 2 persistent services. I already talked about IRODS, should be capitalized in the end, and then the portal service. And I'll show you the portal service in a moment. One thing I really would like to mention, if you're interested in much more details on this, on ExoGENI and GIMI, there will be a 2-hour tutorial tomorrow where we would like to build smaller groups that could sit together with one of us, working on the things, pounding us with questions, telling us your ideas. So tomorrow at oh, wonderful! Thank you, Victor. Tomorrow at 1:30 in room Officers Club. Please come over and at least sniff in if you see if there's something interesting. There's a lot more detail. There will be a lot more time to talk about these things. So the portal service, I'm actually going to demonstrate here today. So GIMI and ExoGENI, we've been working together very, very closely over the past year and a half or even longer. We still don't have a rack. I hope ours shows up at some point in time. So I'm just kidding. But we've been working closely together to have these 2 systems work, or these 2 tools work together. And it has been great because there's a lot of support from the RENCI folks on the needs we have for our measurement platform. The process really to automatically set up measurements while acquiring resources. And we have a certain set of client tools in the user workspace. So for the folks who have downloaded the user workspace VM, the folks who have signed up for tutorials should have gotten a link. Certain tools for GIMI actually on that VM. And we'll talk about this a little bit today. Measurement data, actually when you take a measurement data, it's actually automatically stored in iRods. It goes, the data is centrally collected at an OML server, and then it's going to be pushed over to iRods, where you have a graph to show that a little bit in more detail in a second. You can automatically add metadata, and then the user can actually, through the iRods interface, retrieve that data later on for new analysis. For all of you, you probably know when you do measurements, a lot of the time you spend actually analyzing your data. Actually running a measurement and generating tons of data is really not necessarily too difficult, but analyzing it, making sense of your data is probably the most part of your work. And so we have an iRods client as a workspace. So kind of giving you an idea how things work together here. Oh, and I forgot to change one name here, but that's okay. Is in the tutorial is actually that we have 3 parts. So what you see on the top left here is actually just for now a potential topology, ExoGENI topology, where you have what Victor has shown you already, obtained your slice, there are your resources. What we have done is we have created images that are kind of gamified. So we have certain tools put into these images that when the VM comes up, that offers you these tools, they're already there and you can use them. And so this is just a topology I'm showing here with the resource controllers and the measurement libraries that collect the data and push it back to the OML server. Then we have a persistent node here, persistent server that runs the OML server, the aggregate manager, an XMPP server, where the nodes actually register when they come up and say, hey, I'm actually in an not an open flow node, an Omf node. I can communicate in an experiment. I'm here ready for an experiment. iRods runs there, and then actually please replace iReal by LabWiki. Sorry, I didn't mean to do this on this slide. Our portal to run experiments. There's 2 ways. There's a portal way to run experiments, but you can also run experiments from the user workspace if you want to run certain very specialized individual things. So we're going to have, today we're going to have a little bit of a very specific topology here. It's pretty much the same topology, and I know this is awfully small. What's important here, actually, let me go to the next slide. Here's a little bit bigger. What's important here for this experiment I'm going to show you is actually that I almost took the same topology Victor was showing you in the end. I got rid of toolings we don't use, but what you have to keep in mind here is that we did actually an interact topology, right? So the 4 nodes on the top are actually all VMs that run in the Renzi rack down in
Chapel Hill.
Jeez, my geography is great today, huh? And then we have the 2 nodes, number 2 and number 4 down at the bottom in this blue oval. They run in Cambridge, Massachusetts at BBN. It's nice and snowy today, by the way. As you can see, what we did here is, what I'm trying to do now is actually set up 2 flows and set up one flow that goes in the rack, right? And the return path goes actually via BBN, right? It goes from the Renzi rack over a bunch of virtual networks between 2 BBN nodes and then all the way back to channel 2, right? So that's kind of, actually we see this quite a lot these days, asymmetric routing, so to speak, right? But we're doing this really on layer 2. It's not a routing. And what we do here is just run a simple thing. What kind of implications does that have? How does that perform? And what I've done in addition is actually, I looked at Avior, and I thought Avior is actually really cool if you haven't done OpenFlow before and you want to learn about how to set up flows and all this kind of things. But then I went and used Tremor, and that's a really cool tool. I love that. It's a tool that is you can use Ruby or C to create your own OpenFlow controller, right? And so the nice thing is actually, and I'll come back to this in the end, is actually that Omf and LabWiki and a lot of the tools we are using are also programmed in Ruby. So it's nice to interface with that, right? So what I did is I programmed my own OpenFlow controller just to dynamically, change these flows. Because, doing this over a GUI is great for learning experience, if you really want to do this in an experiment, you want to automate this by a program or by a script, right? So that's what we did here. So what you can think of is actually what's happening is, I wrote this really little program here that actually 30 seconds, I have my return flow, the purple one going this way, and for another 30 seconds I have it going this way. And that goes back and forth all day long because it's so nice. So that's just a simple experiment we've set up here. Now think of it. This is really simple, but I wanted to keep it simple to give you an idea of how you can start with simple things. And then you can actually go bigger and make this 20 nodes and whatever. But now think of it. You came up with a new transport protocol, right? And we have, for example, these kind of asymmetric routes these days. This is actually a nice way to get started in an actual test bed. How does my new protocol behave? And I can do measurements, and I can make them repeatable. Because the beautiful thing with ExoGENI is I can set them up. I can set up this slice again and again and again. You have to be careful, and Victor, correct me if I'm wrong. The only problem we have is actually with the long distance links here, because we don't have any guarantees on these links, right? But this is real work, right? This is what we have in the real world. There's still no quality of service last time I checked in the internet. So that's what's happening. So let me stop here and see if you guys have any questions, because I'm talking about like the setup of the experiment. If you could follow me and saw what I'm doing, what I'm trying to do. Okay, great. That is wonderful. So this is the setup. What is happening here in this case is actually, I talked about already, we have XMPP messaging going on. The nodes, when a node comes up, it actually registers with the XMPP server. So then our experiment controller, which is down here, actually knows how to signal to the nodes, right? And so we can start experiments, stop experiments, send signals, send control commands to the nodes. And then, by that they can actually message to it. And then we do data collection, right? So when an experiment is going on, data from the nodes is actually collected at our persistent server. It goes into the OML server, and we have an automatic storage mechanism for iRODs, where it then really goes into the archive, where you have it stored pretty much long term. You can search it, and we can talk a little bit about it. So the thing we have in mind here, and I'll go back to Flukes and show you something in a second, is actually that your iRODs archive will be your one-stop place where you store everything about your experiment. Your reservation, your NDL description for your reservation for your slice, right? Store it there, because if you have it there with your data, you can come 2 months later, get it back, start your ExoGENI slice, and repeat your experiment. So we're really working on being able to do repeatable experiments over and over and over again.
You might want to show how you get that from there, since
Right.
I missed covering that.
You're miscovering that, so
Yes.
So I'll get to it. I'll get to it in 1 second, okay? I just want to end up with one thing. I talked about Tremor, and that is a full-stack OpenFlow framework in Ruby and in C. It's very easy to use. Even I could program it, right? So that tells you it shouldn't be a problem. Ledwick and Omf also use Ruby, and what I do in this case, actually, I run the controller on a fixed node. Kong, who's my wonderful student who's actually doing all the hard work here, has actually run also experiments where we, in addition to this 6-node infrastructure slice, what we do is we bring up a 7th node, but we don't link it to these nodes. The only thing is we use that management interface, as Victor has shown you before, and then connect to that management interface, and we run the Tremor on that node. You can also run a Floodlight Controller on the node. This works wonderfully, right? So you don't need to have a persistent node for that, just to tell you. The cool thing with that is actually, since we're running this all in Ruby, right? And we're having wonderful OMF tools that can look into our database where the OML server stores all the experiments, we can actually run closed loop experiments. So think of that. We're running an experiment, we're collecting our data in the server. In real time, we're analyzing that data in the server. Based on the data we're getting in our server, we can actually change our flows, right? So that's pretty cool. So you could run that, hopefully, if you don't have any bugs in your code, that would run forever, so to speak. But you can really kind of run controlled experiments that control themselves based on what's happening in the network. I find that pretty nice. It'll take us a couple steps. It'll take you a little bit of getting used to the tools to do this eventually. That's not an easy task, because you're getting a kind of a spaghetti bowl like this, and that makes me a little bit dizzy. Okay, Before I get to the more exciting stuff, here is the links to the tutorials. Just take a look at them, go through them. They should be relatively self-guided, so you can do stuff on your own. And there's also links to the videos I made, just if you want to look at it and see how we do this stuff. It should be very helpful for you to get to this stuff. So this is all boring stuff, I know. So let me look where my flux is. So now here's something funny I want to show you. This is the infrastructure I showed you on the slides. Pretty much the same Victor showed you before. And I don't know. It doesn't make it bigger, I'm sorry. Oh, I got the little watch. Sorry, it's, anyway, I can talk about this. So what you see here is that's what's happening when you get an interact slice. As Victor showed, an interact slice. As Victor showed before, you see now there's all these dynamically provisioned VLANs in between, right? And so that makes the picture a little bit more ugly. But as you can see, you have 6 nodes on here. There's actually node 5 is over here. And I hope my network link, oopsie.
Try changing the graph layout and see if that helps.
Just pull it over here for a second and see if this. Ah, that's fine.
It does that to me too. Maybe probably on the other screen.
It is somewhere on the other screen. Let's see right now here. 1 second, this is the wonderful thing. So, what graph layout should I just take a different one?
Yeah, just pick a different
More fun. So actually here you see where I have node 0 is up here, node 5, these are the 2 nodes I want to have communicate with. These are the 2 other nodes in the Renzi rack, and these are the 2 nodes down at the BBM. So this explains a little bit better. Let me see now when I want to log in where this opens. It's over here. This is a little bit advanced or more challenging here actually. The screens are opening over here. So now I can actually log into my node here. I again apologize. The font is a little bit small here and I'm not getting rid of it. But it's just, you can log into the node. And
Control right click.
Control.
And go down to huge.
Oops.
Yeah. Huge, which is right there. Keep going up. There you go. Do that. There
Oh, wonderful. So here you actually see the node. We can log into it, but I'm just knowing this by heart by now. The other node's IP address. Oh, do we actually have this running right now, Kong? Is the tremor running? Okay. So 168.2.6, we can actually go and run a ping, and we can connect back and forth with that. So, but that's boring because we can do this by hand. We know that, but when things get more scale, when we have larger slices, we don't want to do it by hand. So 2 things I want to show you here is actually, so we got back and forth with the Renzi folks, and it's a stupid menu here. But what I can say is actually, you cannot see it here, but when you go on the file now with the latest version of Flux, you can actually say save manifest to IRODs. Hopefully
If you exit Flux and come back in, it should put the menus on the right screen.
Oh, okay. Let's just, with respect to
That's fine.
time, it's just leave it like it is right now. And so you can actually save it in the directory where you collect your measurement information. One additional thing I want to show you is actually, and we need this later on.
The menu appears on this.
No, I'm just wondering if my X window still open.
Yeah.
Yep. It's not what I want to do. Sorry. Bear with me for 1 second. What I wanted to do is actually show you the properties here. And so Victor talked already a little bit about the post-boot script. And so we're having actually a post-boot script, and there's one thing that's really important when you use GIMI on top of ExoGENI, because we have to follow certain conventions, because when we write our experiment script, we specify VMs by their node names. right? And so in the postboot scripts, we can actually, what we can do is actually, we can, let me go to the resource request view, and we can actually, it shows the postboot script a little bit nicer. We can actually just use the variables. So we have one postboot script for all the nodes in this experiment, because when we create our topology, we give the node names, right? And here with the variables $slice name and $self name, you get actually the name of the slice and you get the name of the node. And we both have to set them because we need to use the slice and the node name later on in our experiment, because that's how we address our resources, right? So that's what we're basically using the postboot script for. Sometimes we're using it also to put some later tools in. And then finally what we do here is actually we activate our resource controller. So at the end, so the VM comes up, it runs the postboot script, and then we set up the resource controller. So what's happening is that node automatically registers with the XMPP server. So it automatically becomes addressable in our experiment, right? There's nothing you have to do. If you set it up this way, you should be all set. So that's coming up. So in this case, we have set up our slice. We get the manifest view. As Victor has shown you before, we can query our manifest. We get the information back that thankfully everything is active. Cool. And so now we can go over to the actual part where we have our experiment. And so where's my browser now? Here's my browser. And so here's what we call LabWiki, developed by the folks at NICTA, which allows us actually to run these experiments. Again, I apologize about the font. There's a whole video and there's a nice tutorial on the webpage where you can see this in more detail. Let me just explain to you what you're seeing here. What you're seeing here is actually, so when you log in, usually there's nothing. The LabWiki comes up empty with these three widgets. The prepare widget, where you prepare your experiment, and what you see here is actually an Omf Experiment Script, right? That is, for the folks who have run OMF or used OMF already know that this is how you describe your experiment. So I define certain properties. So I have a source. I have two source nodes here. And are the two end nodes you have seen before in my topology, node 0 and node 5. I define an application. Here we're just using a normalified ping application. So very easy application. I define a group, and then in the end I define my application, and then I can actually define a graph. And with that graph, it allows me to, in real time, observe an experiment. Just see what's going on. It's kind of a nice thing because you can, while you run your experiment, see is it really working? Are my nodes up? Is the data coming through, and so on. It's probably not the graph you want to use in your paper afterwards. You still might have to go back to the database, take the data, do some polishing on it. But it's really for an observation while your experiment is running. You can even go back, have a cup of coffee, and come back 10 minutes later and see if that experiment is still running fine, or you go to bed at night, next morning you look at the graph and see, ooh, data's still updating. So what you have there is your experiment script. There's a repository where you can store your experiment scripts, and you can either do this in the Git repository or in iRods. I'm just using the Git repository here because it's a little bit faster. And so we just, here you come, I just say, this is my OpenFlow experiment. So that loads up, that's the script I have here. And so now the nice thing is I pull my experiment over here. Something went funny with my browser earlier today, so I just have to hit the reload button. It's one of these demo effects. Now it should be all fine. I put it over here. And it gives me a mask of of certain things I have to fill out before I run my experiment. I'll give it what experiment, I give it a name. That is a bit important because the name is used to for how the experiment is actually stored in the database and then in iRods. And here's the most important thing. I have to give it the same slice name as the slice name I gave when I used flukes to reserve my ExoGENI resources, right? So that's the only point where you have to use your brain memory, so to speak, for a moment, and remember that slice name. We probably shouldn't be too difficult to fix that at some point. Actually, I'm working on something that we can actually pass the manifest and the other comes back, and then we can automate that. That shouldn't be a big thing. And then you can, here you just activate your graph. You can also not activate your graph. Sometimes I've run this experiment 100 times already. That'll go through. I just have to rerun it with a different set of parameters. And I don't want to look at this. It's going to run for a week. I don't need a graph. And then my experiment should nicely start. What's happening here is you get some feedback from the experiment controller on that experiment. And so this is an experiment we run for 300 seconds. And then hopefully, if everything goes well, we get some data back. And this is some typical experiment stuff. Here we go. I think it's more me being patient, right? And so you can see now, this is just round trip times we see over ping, how that is updating. And there's a little chaotic ping here, as you can see. And now you will hopefully see over time, I'm switching that pass. Well, pass just switched. See my flow is different now. And now I'm actually going on a return pass via these two BBN nodes. And sometimes I have these spikes, which I cannot explain right now. But that is, the open VLAN connections we have here. Don't know what's happening there. Don't know what NLR is doing. So that's just, fact of life. But so this, unfortunately, just for this right now, because of the demo, it had to be a huge spike, but you can actually still see a little bit of the ramp on you have. And now, after 30 seconds later, I switch my pass back to just going in the Renzi rack. And so round trip times are, in the milliseconds, they're very, very low. And so now you can observe this experiment and go on and on. I agree, it's not too exciting, but I wanted to show you how you can build a simple experiment which you now could elaborate on. You can build more elaborate topologies with more nodes in it. You could have more links in it. You can now actually go ahead and start running your applications on it and just say, what does it really mean if I have asymmetric, routes going on to my application, to my protocol, to whatever I'm using, and can you evaluate that? And now, while this experiment is running, or when you're done with it, I forgot, I didn't explain you the last widget. We have an actual wiki in that wiki, that's why it has the name. So you can actually go here and then edit this, right? And say, you're running this experiment, and then you can say, they give a demo of GEC16 and get the following result. Save that. This is this funny reload button issue I guess I have. Sometimes it's good to hit the reload button, right? Keeps you active. So then I can actually pull my graph over, and boom, and boom. Not working, huh? Just didn't aim right. So I have it in here in my wiki, and have my result here for documentation, right? You can save that, you can archive that, and so I have the result from my measurement here. While it's going on, it's still updating, so I will probably want to wait until the experiment is over and want to save that. So, that's basically how you can use that. I guess, I'd like to spend the remainder of the time to open the floor for questions. Victor, maybe you want to come back up again and see if there's any combined questions. Again, come see us tomorrow afternoon. We're going to build smaller groups, be able to go in more detailed stuff, detailed questions you might have, and we're looking forward to help you out with your needs in terms of experiments. Yeah, go ahead.
So you're using a number of OVX virtual open source.
Yes.
You have shiny, big, powerful, real
That's true. We do, and you can have access to them, but it has been our experience thus far that many of the controllers that students tend to use are flaky, is the best way of putting it. And while we realize that OpenFlow is supposed to partition portions of the flow space so that the students cannot do damage to the functional part of your production network, we have not necessarily had that experience at all times. So it has actually been a lot more useful to us to be able to do virtual switches inside of ExoGENI rather than necessarily provide access to the hardware switch itself. That having been said, that ability is still there.
I promised, sorry to interrupt you. I promised one thing I almost forgot. And that is, the GPO would like to get your feedback on the things we're doing here. GENI is standing in the back and having evaluation sheets. So fill them out, give us a wonderful grade. No, fill them out and give them your opinion.
Give him a wonderful grade.
And if she doesn't have any, not sufficient number of sheets, there's actually a link where you can get to it and fill it out. Okay, but any other questions?
How
Right.
much scalable is ExoGENI? I mean, what is the maximum number of nodes we can?
Within a given rack. So we book that there will be 100 to a given rack VMs that you could allocate. We take 50 of them and allocate them to the rack SM normally when we do a configuration, although the rack operator has the right to change that as they like. And the other 50 are made available to the ExoSM. So if you're using ExoSM, you have up to 50 VMs that you can use on that rack and on all the other racks that are part of the ExoGENI project. If you choose to use your rack SM, you have 50 and only 50 within that rack. So by the time you're all said and done, 14 racks plus however many get bought or added by other institutions and choose to join in and have resources delegated to ExoSM. But at a minimum, it'll be 50 times 14. Yep. So roughly 700.
Bob. Okay, any other questions? Okay, thank you very much for coming. Hope you can take home a little bit of what we showed you today. We're also going to be around for coffee break. I need one definitely now. And if you have any questions, we'd be more than happy to talk to you individually. There's also maybe if Jonathan, Kong, Divya and Dilip, I don't know who else, Yufang is here. If they could just raise their hands. Could you guys raise your hands? They know probably even much more than I do about all this stuff. So if you see them and want to bug them about it, feel free to do that and ask them questions. Okay? Thank you very much. Yeah.